All right, guys, so Johnny already told you what TypeScript is all about, right? That was pretty cool. So now let's think about how we can actually take it to a whole new level and make your static typing go a little bit mad. My name is Molak. I'm an independent consultant and technical coach helping teams around the world deliver better software. Now, what I really like to do is I like to spot things that work. I like to distill them into patterns and share them with community. Often in the form of open source projects, such as the build monitor for Jenkins or Serenity.js, my acceptance testing framework. But tonight, we won't be talking about any of those things. Instead, I would like to introduce you to a little design pattern, actually quite tiny one. And excuse my terrible pun. So, have any one of you ever heard about TinyTypes? Marvelous, you're in for a treat. Brilliant. Okay, yeah, it's pretty much the same thing. So the pattern itself has been around for quite a long time. So I've learned about it from a friend of mine, Andy Palmer, who pointed me to this article by Mr. Darren Hobbs from 2007, where he describes the pattern in, well, as pretty much one-liner. So it's basically, the idea is to encapsulate the simple built-in types, such as string or number or array, for example, within domain-specific classes. Now, the concept itself is not particularly new. So I managed to trace it back all the way to around 1994, which is like ages ago in the JavaScript space, where Ward Cunningham described it on the C2 wiki. So that was the one for the Chrysler project, one of the very significant ones in the Agile space. Now, Eric Evans describes a very similar idea in his book from 2003, Domain-Driven Design. Now, Von Vernon talks about it as well, same as Martin Fowler. So, if you think about it, if this pattern is so simple, why would so many people actually describe it? Yeah, it's just one line. But what's really cool about TinyTypes is even though the pattern itself is quite tiny, the benefits of using it can be quite huge. But the patterns on their own are great, but what really matters is how you actually apply them, how you implement them. Yeah? So let's talk about TinyTypes using a concrete example. So let's say we wanted to implement a, let's say, online banking platform. I tend to work a lot with clients in the financial space, so it's quite a familiar domain to me. So let's say we want to enable our customers to be able to make payments online. Crazy functionality, right? So what we need to do is we need to build some sort of front end, probably to capture the data about the payment, about the accounts, and so on, send it to the backend and process it. So at some point, we'll probably need to write a function along those lines. Yeah, make a payment from, to, reference, amount. Now here's a quiz for you. If you needed to call this function from your code, what would be the format of arguments you need to provide? It's not that obvious, is it? Yeah? Not at all. Now, what often happens when we write code is that the intention is very clear to us when we write it, but it's not at all clear to the readers of this code. And quite often, those readers of the same code could be us just a few months later. So now, what is the from? What is the to? Are those the account details, the IBAN number, the address? Well, it's hard to tell. Even the reference, yeah, well, that could probably be quite simple. It's probably a string, maybe, but we're not sure. Now, my absolute favorite, the amount. What is this, a number, a string? A string in what format? Hell knows. So let's use TypeScript to make some magic happen and make it all way better. And we introduce types, and now we've got, oh, I'm so sorry, it didn't quite go as well as planned. So, you see, even though we've got types here, that didn't really help much, yeah? Everything is still a string. So we've kind of captured the types of the primitives, yeah, but what we didn't do is we didn't capture the opportunity to actually express our intent clearly, to help the developers who will be working with this code. Well, we're actually not being too nice to the compiler either, because if we just mark a property as a string, the compiler won't be able to help us. it's still very easy to make silly mistakes, like get the order of parameters wrong. Yeah? I could quite easily here confuse the reference with an amount. So how about we actually give TypeScript a chance to help us? How about we try to capture those domain concepts and treat them as first-class citizens in our system? How about we express the from as payer account details? Now it's quite clear, yeah? We know what that is. The two payee account details. Now the first benefit straight away is that, well, we can't really confuse the from and the to account numbers, yeah? It's already slightly better. We could do the same thing for the payment reference, same for the money. Now, with this approach, the intent becomes much more clear. It's much more obvious what we as an implementer of this method intended to express. We also provide additional help to the compiler. Now, if you think about it, if you wanted to refactor and change the name of this class, well, you just use your tools. Yeah? The compiler can very easily support you. On the other hand, if you ever try to find usages of a string in a large code base, you know what I'm talking about. So another good thing about this is that we could use those domain types on both front-end and back-end. We could actually reuse the same code. We could take full advantage of using the same language in those two places. So how would we actually implement those tiny types? So the way I like to do this, I like to implement those things as classes. And I'll explain why in a second. So here you see that the payment reference, for example, is just a really lightweight wrapper around the string. Yeah, just an object, takes a string in. So how would we implement it? Well, we'd probably create a class, we'd call it a payment reference to capture the domain meaning. We'd create a single argument constructor that takes a reference string, assigns it to a field. So what's so cool about it? Absolutely nothing. What we can actually do with this one is we can actually capture a couple of opportunities. So first of all, we could make our object immutable. And there's a nice modifier in TypeScript called read-only. If we mark our fields as read-only, it means that they cannot be changed or reassigned after the object's already been constructed. Now, there's another little trick we can use. So TypeScript allows you to specify the parameters as properties when you create the object. So this syntax here will define a class that has one field called reference. That's also immutable. So as you can see here, I can actually express this type in just a few lines of code. But that's not the main benefit of TinyTypes or microtypes. One thing that this can give you is an opportunity to introduce consolidated validation. Big words, yeah? So think about all the different places in your system where you need to validate data, validate user input, okay? So when you think about validation, we often think about the user interface. Obviously, someone enters the value in the form, we have to validate it. But what about all the other places where we need to read some value from a CSV file or from JSON, where we've got the HTTP API that receives a JSON payload over the wire, or from a message bus? There's quite a few places where we actually need to make sure that whatever data we've been sent is valid, that we can use it. So think about all the different validators type we've got in our code bases. Now, how could we improve that? So let's think about this whole payment reference for a minute. So right now, the payment reference is just a lightweight wrapper around the string. But now, is payment reference really just any string? Well, it's not, right? For example, well, it has to be defined, yeah? It could be empty, but it has to be defined. If we get a null or an undefined, that's not a valid state of our system. Also, in most banking systems, those payment references, they can't be longer than 18 characters. So if we ever get a value that's longer than 80 characters, that's not a valid state either. So what we could do, if we represented those concepts as classes, we could actually implement validation right there in the constructor. What this gives us is an opportunity to ensure runtime correctness of our system. It's virtually impossible to construct an invalid payment reference, because this thing will throw an exception or an error. Now, we could apply the same logic to composite types. So you remember I told you about money being one of my absolute favorite types because it's just represented so many different ways in so many different systems. Now, in 2003, in his book called Patterns of Enterprise Architecture, Enterprise Application Architecture, Fowler proposed that money should be represented as a composite type of amount and currency. Now, we could do this quite easily with TinyTypes. Here, I've defined a class called money. It's got two properties, amount and currency, and they both have their own respective types. Now, I could also say that it's incorrect in my system to have a representation of money that doesn't have currency or an amount. They both have to be present in order for this thing to work. Now, this gives me another opportunity. If I describe the amount as a separate type, I could say that it's invalid in my system to have a negative amount of money, for instance. So where do I input this logic? Well, I've got a class for that. That's quite easy. Now, if we decide to use this sort of pattern and then use those classes consistently on both front-end and back-end or whatever microservices we're using, then it's almost impossible for the entire system to ever be in an invalid state, which is quite big if you think about it. But that's not just that. It's not only about throwing the errors. Another thing that TinyTypes give us is a natural place to put the low-level domain logic. Okay, so think about this whole class of money again. What about low-level operations, like adding or subtracting, yeah? Or calculating a percentage discount? Where should we put it? Well, there you go. That's your place. No longer need to put it in some sort of a separate validator or data service or anything like that. That's my domain type. That's its logic. The methods themselves can benefit from validation as well. So, for example, well, we could say that it's impossible in our system to add two amounts in different currencies. So this way we can build very strict domain models that are particularly well suited to domains that actually care about being correct, like functional space. Now, if you see the trick I used here, I'm actually still using immutable objects. So when you add one instance of money to another, I'm just returning a new instance. So all my instances are immutable. Now, the cool thing about this is that systems relying on immutable data structures are much easier to reason about. They're much easier to debug. There's no mutation of state anywhere. Yeah? What you can also do with those things, you can send them over the wire. You can reuse them in front-end and back-end and so on. Now, I tend to use this pattern quite often. I mean, I've used it in Java, in Scala, in JavaScript, and recently in TypeScript. And some languages are obviously better suited for it than others. Yes, I am looking at you, Java, with 40 lines of code per type. Yeah, exactly. So what I did in TypeScript, I created a little library. So you can implement this pattern with no libraries whatsoever. You don't have to use it. So the one I created has no dependencies. It's got fairly decent code coverage and so on. So what does this thing give you? I noticed that I actually need to do this whole validation of state in quite a few places. I do this in constructors, I do this in methods. So I created predicates. What predicates are, they are a little DSL, a little domain-specific language that allow me to express the constraints around specific domain objects or specific TinyTypes. So if you remember this whole payment reference from the earlier example, here I've replaced my bunch of if statements with this little ensure block. So here I say that, well, I want to ensure that the reference is defined, that has the property of length that's less than 18. Now, all this stuff is type safe, so I wouldn't be able to say in my DSL that the length is less than another string. It actually verifies that this is a number. Now, what this gives me, it also produces quite sensible error messages. For example, if I want to create a payment reference with no argument, I'll get an error. Reference should be defined. If I try to put too many characters, well, reference should have a length that's less than 18 and so on. And it's very easy to extend those predicates with the ones you need for your domain. So let's talk about comparing those values, because one of the things with representing those primitive types as objects, well, how do you actually compare them? Yeah, because you can no longer use the triple equals operator. That will not work, because that compares objects by reference. Here, we want to compare them by value. So that's a slightly different thing. So what I typically do here is I use a little equals function that comes with the TinyTypes library. So what this thing does, it will go through all the significant fields, so through all the different member fields of your objects, and then compare those things by value rather than by reference. Now, if you don't like extending any framework classes, you don't have to. You can just grab a function and use that on an existing type. If you prefer to have less boilerplate, you can just say that this particular type extends TinyType, and you get the equals function. Now, the way the equals function works is, let me show you an example. So here you see I'm creating two different objects. So I'm creating two money objects. Both of them have an amount. Both of them have a currency. So I can actually compare them, and the equal functions will go recursively through them, comparing the different properties to ensure that both values are the same. Now, what about serialization? Another thing with building distributed systems, especially in the microservices era, is how do we actually send a given object over the wire? How do we ensure that it remains intact, that we serialize and deserialize it correctly? So the typical way to do it in our JavaScript world is to add the two JSON methods on those classes. And you can do this as well. Now, what you can see I'm doing here is basically the JSON method from the TinyType will go through all the different member fields, and if your member field happens to be a class embedding just one primitive, it will serialize it to that one primitive. So you get a fairly nice and clean JSON structures out of this implementation. But I think the one I'm actually most happy with is no more object. If you ever try to console log a type in JavaScript, you know what I'm talking about. Yeah. I see some smiles, brilliant. So that's actually one of the first things I replaced. So what this one does, it will actually, again, go through all your significant fields, figure out their types, and tell you what the values are. But I came across another interesting use case for the functionality of overriding to string. GDPR, data protection. So if we represented, let's say, a card number as a TinyType, we could override the toString method on it. We could ensure that whenever we print someone's card number, we always mask it. So that was quite a surprising use case that one of my students came up with on a recent project, which is pretty cool. Okay, so let's talk about the big benefits of TinyTypes. I think one of my favorites is the clarity of intent. I really like being able to use the full power of TypeScript to express what I meant by the specific piece of code. And I like the code to be obvious to me as well. Now, if you think about it, the code that you write is much more often read than it is written. So it's actually quite important to optimize it for readability. Better tooling support. I mean, TypeScript compiler is actually pretty amazing. Tools like the Visual Studio Code or IntelliJ or WebStorm, they're very good at supporting our development efforts, but we need to help them out a little bit as well. If we just represent our types as strings and numbers, they won't be able to do as good of a job. Immutability. So I like to ensure that all the data structures I work with are immutable. And this pattern helps me with that as well. The validation is quite a big plus as well. So this way I ensure that it's impossible in my system to construct an invalid type. This means that if I use the same classes on both frontend and backend, all the different parts of my system ensure that the type is correct. And better encapsulation. So let's think about this one for a moment. So let's say I wanted to suddenly change how I represent money in my system from a number to a string, or use a new library like big number or big JS. Where would I do it? Well, if I have a type representing the amount, I could just use big JS under the hood. quite easily, right? I don't have to change the interface that my clients are using. So it gives us quite a few opportunities that can help us build better, more reliable systems that express their intent in a much cleaner manner. Thank you so much for your attention.